Yeah. Already setting up the sound.
Yeah.
Yeah, I finished. I start the Zoom meeting and I connect the audio and the USB and
Yep.
is anything I should do?
No,
That's all.
yep. And then that's for the audio, and then you're gonna have your slideshow
Yeah.
there, which
Oh.
is gonna go at the top there.
Yeah.
Yeah.
On the laptop.
Would I just go in between speakers, just click on the next one, etc.?
You can do that, or we also have a remote clicker
Oh,
if you
okay.
want to use that.
I'll probably just do this more reliable, I guess, because I don't want to fucking like start and start fishing with it.
Yeah,
Might as well
you
just
can
go
do
for it.
whatever, man.
Yeah.
But yeah, the laptop, the HDMI cable is just on the top of the lectern there.
sweet.
The plus the webcam is also there.
Webcam, okay.
Yeah, that's got a USB-C connection.
Mhm.
Pretty sure.
Oh, yeah, right. Cool. So I don't have to use the computer one.
Yeah.
Automatically connect.
Yeah, there's a USB-C cable
Yeah, okay.
specific for that webcam,
Okay.
but you can use that one if you want, whatever you want.
Sweet. Other than that,
Yeah.
I think that's all.
Yeah, if you need any more help, I'll be outside.
Thank you.
Okay, thank you. Actually, Lan, can you send that link to me? Because I don't have the Viva.
Sure. James. Okay. Let me just
I think
I can find
it'll
it. That's
do some of your business analytics on it.
James I'm not sure.
I think I can find
Invite people. Okay. I find the way. And yeah, this year, right?
Yeah.
Okay.
Oh, there's gonna be a copy.
Me too. Do we need to stay here? Like, I think it's
so.
early. Like,
Fine. I'll just be back here at 10:15. So I'm gonna set up the.
yeah, no.
Yeah, one all slides, so. Let me just test the, I'll go on the project the pedals and on.
So you use your personal account or?
Yeah, I should join with that first
yeah.
one, I think. That's what the instructions said.
Yeah. Is that online speaker today?
Oh, I don't think so,
Okay.
but I just wanted. Your old hair, short hair.
Yeah, because it's like almost 8 years picture.
I couldn't recognize.
Yeah, because it's
They're
it's
short.
very long time ago. So the last year you are the owner.
Hmm?
You're doing the owner.
Yeah. Oh, next year.
Oh, next year.
Can you promote me?
Yeah, sure.
I need to get the
Yeah.
my in. Oh yeah. Sure.
Yeah. 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 The panelists. Okay. Uh,
So,
okay.
should
Yeah.
Where you want, that way, yeah. I'll be back.
Okay.
Yeah, I'll be fine. Yeah. I think. Yeah, that one. That's all helping you today, you know? Yeah.
It's the audio work, right?
The audio, so that's gonna come back around. You getting the audio?
Yeah.
Yeah. Cool. Can you test the mics? Cool.
Testing.
Just, how loud would you like it? You see this knob here? That's the volume for
Oh,
the,
okay.
for the mic.
Yeah.
We'll let the presenter figure it out.
Okay, but yeah, it's just this knob here.
Okay.
Turn that.
How about if they have online speaker or
Sorry?
if they have online speaker?
That should control everything.
Oh, okay, cool. Thank you.
Um, yeah, so, but this one knob will increase and decrease
Yeah.
everything the same, so like, if you want the laptop to be like louder than the other one, then put the laptop louder by itself.
So I need to.
Yeah, that, oh, that's muted.
Yeah, okay.
But, okay, so, but yeah, we'll
Okay.
figure it out, yeah.
Okay, okay.
But that's, at least for the microphone.
I mean, this is just mute my system.
Yeah,
from
that means
somewhere.
the system. This one is the control for the
Oh,
plug.
oh, thank you. Okay, that's good. Oh, good.
Yep. Yeah.
Thank you so much.
I'll probably just see it. I think you're lucky you don't get a really transition. Like, what happens if I switch to the next guy? It's gonna look like. Oh, that's it. Oh, it'll be centralized. So I'll just come up, I'll just be in the front row and I'll just change. I change. Yeah. I'll scrap the schedule, have this. Yeah, they're already here. I believe harmful. Yes. This one? Yes. Just double shot. Present view. Boom. There we go. How do you want it? Any one mic? Anything special? Oh, good. Thanks. Oh, good. And then share screen as well. Oh, share.
No, not on my phone.
Yes. Oh, okay. Oh. I was wondering why I was seeing two names. I was like, yes. Tennessee. Okay. Yeah, sweet. No worries. This is the first one they're on.
Yeah. Forgot one.
Yeah.
This.
I'll get another one as well. Yeah. Okay. No, essentially. Yeah, you have, I'll double check. Catalog, ready, 3, 2, 1, boom. No one, that's the one. Okay. So what will happen is in between talk. Want to check the camera setup and everything, so it's suited for you. It's all good. I just went, yeah, perfect. Just double check everything. I'm gonna do it, process it on road, then manually switch the slides. Over the Zoom, there is no. Give it one moment. Sorry. Oh, yeah, let me go into the meeting, because I think the Zoom link. Uh, white arrow.
start this session. So today's session is we will have several papers and topics related to security. And today's topic is phishing, deception, and consumer risks. Let's welcome our first presenter. The paper is about phishing.
My name is Temporal. How's everyone doing? That's good. Yeah, I don't see that many people in the security session, and it feels like we're the lone survivor against the attackers. So let's fight against the attackers. So today I'm going to talk about the 7 days later, the analyzing phishing sites, lifespan after detected. So my name is Kamchani. I'm from University of Tennessee. So phishing attacks has been out there for a long time, but people still fall into the phishing attack, and new phishing arises every day. Phishing attacks post urgent messages to lure victims, and these are some of the examples of the phishing messages. So in the recent few years, the USPS phishing attack has been increased a lot, and as shown in this example, they include the phishing website's link in the text message or email. They create an urgent message to lure victims to click those links. So when the victims click those links, they are directed to the phishing websites. So let's see how people fall into the phishing attacks. So when victims click the link, they will be directed to the phishing website, and that looks very similar to the benign websites. And people fall into the phishing attack because they look very similar to benign website, or even look exactly the same as a benign website. So let's see why phishing attacks are important. Even though the phishing attacks has been existed for a long time, it's almost over 30 years now, and it keeps growing and increasing and persisting in our life. So this means that even though the researchers put hard work against the phishing attackers, creating the defense mechanisms and detecting phishing attacks, and attackers still put out new attacks every day. So let's look at how phishing attacks work. So let's say we have attacker and victims. So attacker sends out the phishing website URL to the victims. Then the victims click the phishing link, then enter their credentials to the phishing websites. Then attacker collects the credentials from the victims. Then how does the phishing defense work? First, attacker sends the phishing websites to victims. Then defender checks those phishing links and determine whether it's a phishing or not. If it's determined as a phishing, the defender blocks the phishing websites. Then victim sees the block page when they're trying to access the phishing websites. So they are no longer able to access the phishing website anymore. That's the theory, but is it true in our real life? And after the phishing website has been detected and listed in a block list, what happens to the phishing website? So with that question in our mind, we want to ask our main research question. So how do phishing websites stay alive or change after detection? So the motivation of our work is that the phishing website do not get removed right after they're detected or listed in a block list. And to understand further how phishing websites behave after detection, we want to see the lifespan of the phishing websites. Then we want to see the factors that possibly cause phishing websites to be no longer accessible. And lastly, we want to see if phishing websites pose any changes in their contents. To answer our research question, we collected our data set from the block list, such as APWG and double safe browsing. They're one of the most widely used block lists in the world. So with the URLs of the phishing website, we collect the phishing websites periodically, and we collect the status code, screenshots, HTML data, DNS data, and also error code to see when the website is no longer accessible. So we collected this data for over 5 months period. So let me show the overview of our work. So we first collect the URLs from APWG block list, which contains the phishing URLs. Then we access those phishing websites. When accessing those phishing websites, we collect the data sets, including timestamp of when we access them, and DNS information, screenshots, and etc. So then we periodically access the same URLs every 30 minutes until we are no longer accessible to the phishing websites. Then with our collected data, we are going to analyze the lifespan of the phishing website after the detection. And we're also going to look at the error codes, why the phishing website has been taken down. And also lastly, we want to see if there's any component changes. So as for the results, we found that the average lifespan after the detection is a little over 2 days, and with a median of 5.46 hours. However, some of them remain over 30 days. And when we look at the different targeted brand, social media, such as Facebook or Instagram, persist longer than others. And on the other side, logistic brand, such as USPS or DHL, live much shorter than others. We also check the lifespan of each phishing website by different brands. So this CDF graph shows that the different lifespan by different target brands. As you can see here, about 50% of phishing websites are taken down very quickly within 5 hours. And as you can see in the graph here, the red and purple line shows the Facebook and Instagram brands, and the blue and green line shows the that's the other way side. The red and purple shows the USPS and DHL, and the blue and green line shows that Facebook and Instagram, they are detected much slower than the logistic brands. We also compare with the full site browsing detected URLs. So when we look at the overlap between APWG and the Google site browsing, interestingly, we only found that 18% is only the overlap between two block lists. So obviously that shows that those two block lists doesn't share their list of phishing URLs. And another interesting finding is that those URLs that has been detected by Google site browsing persist longer than APWG for up to 7.2 days. Also, when we look at by different brands, the detection speed also differs in this case as well. So when we look at the CDF graph here, the line shows that it's a lifespan detected by APWG, and the vertical bar shows the median time of detected by full site browsing. One of the interesting findings is that the USB targeted brand got detected much earlier in the APWG. However, the URLs that are detected by GSP Google site browsing are detected much later. And we also look at what are possible causes of phishing websites that are taken down. So when we access the phishing website, we collected the error messages. So from our collection, we found that DNS resolution error is most appeared in the error. But it is different by brand and by web hosting and self-hosted servers. So here we also divided our servers by web hosting servers and self-hosted server. Since web hosting servers such as WordPress or Wix may have different impact, since attacker may not be able to control those websites that are hosted on their services when compared to the self-hosted servers. So error patterns are differ by different targeted brand and different hosting services. Then lastly, we also look at the any visual content changes after the phishing website has been detected. So when we check the visual changes, some websites change the whole website contents. to totally different websites. For example, they can be changed from one brand to another brand of the website. And there are other websites that only changes few components of the website, such as logo or login form placements. So we kept track of any changes within components and comparing screenshots to see if there has been any changes with the same websites. We found that the websites with over 100 changes during our collection period last median of 17 days, and the website with single change stayed only for less than 2 hours in median. And another finding is that we checked the CDN usage of each website. When we check the CDN and the targeted brands, interestingly, the social media brands use more CDNs than others. And similar here, the logistic brands use less CDN, and the number of the changes are different as well. So social media brands, targeted brand websites changes more frequently, and on the other side, the logistic brands changes less frequently. So yeah, the takeaway from our study is that the phishing websites lives about a little over 2 days in average after the detection. And we also found that the Google Safe Browsing has detection delay when compared to other browsers such as APWG. And when we look at the error causes when we try to access the phishing websites, DNS resolution errors are most common. And lastly, websites that are frequently change their contents, they survive longer than others. So that's it for this talk. And if you have any questions, please feel free to ask me. Thanks for listening.
They don't necessarily tell you about so more
So that was thanks for the great question, and that was one of the motivation of our research. If I may quickly begin the slide. It's taking so long. So I'm just gonna answer that the like of Google Safe Browsing, like you mentioned, does not actually take down the phishing website directly. So that brought up our research question that so phishing website may stay alive after the detection. So we wanted to see how they stay alive and what could be possible reasons when they are removed from the web itself. So the error causes we found is when we try to access those websites periodically, and those are the causes we got back from the website when we access them. So that those error causes do not show the exact reason why the website has been taken down exactly, but this gives us one direction to where we can look into. Yes. So as far as we know, the detection does not directly affect in the web hosting services in our case. And thanks for the question. And I think that could be another interesting future work that we can look into. Yes. Yes. If I remember correctly, the median was less than 5 hours. Yes.
So most of them
Taken out very quickly. Yes. Yes.
A very naive question. A phishing expedition can create, at this point, can create as many hosting sites as they want, for very little investment. So they can, set up as many places, for the future as they need. The mean time to open an email is less than a day. So, in fact, if you detect them in one day instead of 4, the site's finished with anything. Are you playing an impossible game with that one?
Yeah, thanks for the interesting question. It is actually cat and mouse game, so it is as of its current status, it is impossible to catch at the time. So I also show it to you later on the slide, later talk. The best time to detect a phishing website is when they register domain. However, in this work, we show that we want to see how phishing websites stay alive even after the detection. So the best way to detect or take down the phishing website would be, of course, take them down as early as possible. So, does it answer the question? If you want to discuss a little more, we can discuss after.
So, one of your presentation, I showed that one of the 5 different sites are detected by I think that the chance to analyze the detected characteristics detected one I know why
Thanks for the great question. In this work, we manually look at few samples. Few of the reasons that Google Search wasn't able to detect a certain website was that we found 2 reasons. One of them was the phishing website was using the non-English based languages on their website. There was the Google Search browsing was not able to detect those non-English based websites. And another part is that when phishing website use CAPTCHA, like when you need to click the button or choose the picture, Google Search browsing was not able to detect those websites contain the CAPTCHA with other contents in the same web page. So that was a brief touching surface of why some of the websites are not detected by Google Search browsing, and we're in the process of looking into why Google Search browsing might not detect those type of phishing websites. See everyone again. And thankfully, I got the chance to present 2 papers today's talk. So for those people who came in later, my name is Lee. I am from University of Tennessee. This one is totally different research, but still focused on phishing attacks. So we're looking at a different point of view in phishing attacks, and we're going to answer different research questions. So first, let's look at the life cycle of phishing attacks. So during the phishing attack life cycle, we have attacker and defender. First, attacker creates their phishing websites. Then attacker registers a domain. Then they distribute phishing website through text message or email. Then when the defender or detector detects those phishing websites, they put in their ground list and displays a warning to users or possible victims. After the detection, the website goes to offline. So between these life cycle period, between the domain registration until the website goes to offline fully, the attacker can take the credentials from victims and monetize them. As one of the listeners has asked a question that it would be best to detect the phishing at stage 2 at the registration time. But in this research, we're going to focus on the time frame after the detection. So the phishing website accessible after the detection. As we have seen from previous presentation, it is they are still alive. And from our data set, we found that nearly 80% of phishing websites are still accessible after the blacklist. And this is one of the previous research from another researcher. This shows the visitor traffic on phishing websites. This figure shows that the first victim visit in the time frame, and also the time where the website has been listed as a blacklist. And lastly, they also show the time frame of when the last victim has visited. So as you can see in this figure, almost nearly half of the victims visit the phishing website even after they are listed in a blacklist. So we want to ask why victims still access phishing websites. So the current detection method, one of the largest method, is the blacklisting and Google safe browsing services to the public, and when they have a list of phishing websites in their list, they provide a warning when users or potential victims try to access the suspicious URL. However, if users choose to, they can bypass the warning message and they can click through this warning and move on to the phishing website. So we want to ask our research question. Victims can visit phishing website even after they're blacklisted. But how can you possibly prevent victims from visiting phishing websites? And possibly instead of the reactive nature of the blacklist detection method, how can we actively disrupt the phishing attacks? So to answer our research question, we collected the phishing websites data set. In this work, we collected the HTTP headers and phishing kits from accessing the list of URLs we have collected from the blacklist, such as APWG. So we collected for 31 months in period. For kits, when we access the phishing URLs, we look for all different subdomains in the domain list, and we look for any archive data sets such as zip file or tar files. So our first question is that to proactively defend the phishing attacks, what are possible weaknesses in phishing websites and how that can be exploited against the phishing attacks? So when we look at our research question, one of the possible weaknesses we found when we compared with the benign websites, phishing websites tends to use do not set the security related configurations on their servers. So to find the weaknesses in configurations in server settings, we wanted to look at the HTTP headers. So this is the example of the HTTP headers. So this displays the information about the server. Sometimes it contains the version of the server that this web server is using. And also it provides some mitigation against client-side attacks such as cross-site script attacks. So since we've seen that when compared to the benign websites, the phishing websites do not set the security-related headers on their website. So we wanted to look at a little bit deeper into security-related headers used in phishing websites. So here as well, we divided the servers used in phishing websites into two categories. One is the content publishing servers, and another is the self-hosted servers. So content publishing services means the for example, WordPress or Wix. Attacker can simply use their platform to host their websites. So the reason why we divided these two categories is that when attackers use content publishing services, they have less control over their servers, and they may not be able to set security-related settings in their servers. So when we look at the general headers, such as content type, both content publishing services and the self-hosting servers, they both use high percentage of these headers. However, when you look at the security-related headers such as X content type options or X cross-site script protections, the self-hosting servers do not set these headers as much as the content publishing services. So as we've seen that the phishing attackers do not set security-related settings on their headers on their website. So we think that this could be one of the weaknesses on the phishing website. So we wanted to dig a little bit deeper into what kind of the settings and on their servers that we can possibly exploit to detect phishing websites, phishing attacks. So our second research question is that can we utilize these weaknesses in phishing websites to actively detect phishing websites? So let me show you a little bit about what phishing kits are. So phishing kits help phishing attackers create a phishing website easily. So it is a pre-configured the resources that contains the server-side code such as PHP, also contains client-side code, HTML code, and sometimes they contain logo images or even background images of the websites. So when attacker deploys the phishing kits, this is one of the example. They can choose to decide what kind of the targeted brand they want to display on their phishing website. In this case, the attacker displays Amazon. And with a simple configuration difference, they can change the target message to a different brands. So with the phishing kits, since it has the server-side code such as PHP in their phishing kits, we wanted to look at what kind of weaknesses they had. So we ran the static analysis tool to look at the common weaknesses. So from our result, cross-site scripting and SQL injections are most commonly found in the phishing kits. So I'm going to show you some of the examples of the those two attacks, those two vulnerabilities. So this is the example from the phishing kits that pose cross-site script vulnerabilities. So in this code, these two lines do not sanitize the input, so it is possible to exploit the cross-site vulnerability against the phishing website. So with the cross-site script vulnerability, you can possibly redirect the victims by inserting redirection URL to the phishing website. So this is another example we found from our phishing kits that phishing kits intentionally remove the content security policy headers. These headers, without the content security policy headers, the cross-site script attack is more feasible. And lastly, we found the SQL injection is also feasible in the phishing kits. This is the example of the insecure code implemented in phishing kits. And also with the SQL injection, we can possibly remove taken victims' information or disrupt the database to make the phishing website inoperable. Also, we found interesting backwards in the phishing kits. This example shows the control panel of one of the phishing kits, phishing website deployed by phishing kits. So we believe that the phishing kit creator may have created the backdoor to access phishing websites when it is deployed in the wild. And they can also take the credentials from victims' credentials. And some phishing kits expose this kind of the backdoors open to access by anyone. So with access to the control panel like this, we can see how attackers manage their website using the phishing kits, and we can find the possible weak points of the phishing websites to exploit them. So as I mentioned in the beginning of the slide, it would be best to stop the phishing attacks in the beginning of the phishing life cycle. But if we utilize these weaknesses as shown in this presentation, but we can prevent almost half of the victims by accessing the phishing website. So even after the phishing website is listed in a blacklist, we can still disrupt the phishing website and prevent those half of the victims accessing those phishing websites. So attacks discussed in today's presentation can be done on a website that is determined as a phishing. So this should reduce the number of the victims accessing the phishing website. So as a result, we saw that the phishing attackers do not set the security configuration as much as the benign website, and phishing attackers often consist of weakness and such as the cross-site script attack vulnerabilities and SQL injection vulnerabilities. And by utilizing those weaknesses, we can possibly do the action of the proactive detection to disrupt the phishing attacks. And thanks for listening to my presentation.
Sitting on a shared server somewhere, let's say, Compton Memorial Hospital. And you go in and you disrupt it, crashing the server. This causes some sort of damage to some third party. Who's liable?
Thanks for a great question. That is also remain in the ethical issue of our research. So in our case, we show the possibility of the disrupting phishing attacks, but we need to be careful whether the phishing attack is hosted on their servers, and we're not attacking against compromised servers.
When you collected the data, how many different threat actors do those websites represent? And then what percentage of the phishing websites had the severe vulnerabilities that would allow you to compromise them?
Thanks for the great question. So about the severity of the compromise, let me show you the list of the weaknesses we found. You should be able to find the severity in the paper. These CWEs in the list have high severity. And as far as the data set we have collected, we haven't looked much deeper into the what are the actors behind it. I shouldn't say simply, but we simply measure the what kind of the weaknesses those phishing kits and the website data website the contents contains. So that will be great future work that we can look into. Thank you.
My question is that, can you have a chance to check whether the web services are possible internet enable the configuration market?
Yes, we have tried not all of the servers yet, but a couple of the samples. I think if I remember correctly, we checked the adoption engineers. They do set the basic the header settings or security mitigation settings, such as like process scripting mitigation in by default, so that when we deploy the batch servers, those settings are default in the settings. So some of the cases, as we saw in one of the examples, the attacker sometimes they intentionally remove those security settings. We haven't looked into why those reasons could be, but that would be interesting to find out why they attackers remove those settings.
Hello everyone. Today I'm going to present our paper, Catalog Exploiting Joint Temporal Dependencies for Enhanced Phishing Detection on Ethereum. So these are the contents for today's presentation. So let me start with a brief introduction to Ethereum, which is the second largest cryptocurrency with the cryptocurrency Ether, whose value is around 1500 US dollar. It keeps fluctuating. So Ethereum is famous due to its anonymous architecture like other blockchain networks, and it is ease of use, and also it provides different application of distributed architecture and smart contracts. With this rising popularity of Ethereum, the daily transaction rate on Ethereum is 1.5 million transactions, and the number of user accounts so far is 3.2 million users. So that's quite big. That makes it a large transaction network. So with the dire popularity of the Ethereum platform, there is a rise in cryptocurrency attacks like phishing, which leads up to with 50% attacks on Ethereum. So with what is a phishing attack? That my fellow researchers already explained in case of traditional phishing attacks. But on Ethereum, it is a slight different. In case of Ethereum, phishing attackers often try to manipulate the novice users with the lure of investment traps with a malicious account address. With this address, when the novice user fall prey, then it gets of funds. Now, what is the different challenges for this particular thing? When the attacker is trying to get blended with the normal user behavior so that they can gain trust from the normal users. That's the main challenge over here. So there's a dire need for efficient detection mechanism. So the existing research taxonomy on this particular domain is divided into two major methodologies. One is the static methodology and the other one is the dynamic methodology. Before I move on to the research gaps, I would like to mention some major challenges on this domain. So what are the challenges? As we can see in this graph, that there is a 50 phishing and 50 non-phishing users. I have plotted it with respect to the timestamps and amount transacted in input and output. You cannot differentiate their behavior based on their amount. If we remove the color, there's no difference between these two graphs. That is the major challenge, this similarity in user behavior. Next one is look at the first graph. We have plotted the activity chart of 50 users on Ethereum with respect to their active or non-active. If there is a dot, it is active. Green dot means non-phishing and red dot means phishing. And if there is no dot, it is inactive. We can see there are a sheer long gaps between the activity because not everybody is investing regularly on crypto market. If they are investing regularly, they might be a business wallet. But if you target a normal user who is a normal investor, they won't regularly invest on cryptocurrency. And the other hand, we are plotting the Ether price fluctuation chart, which is very correlated with the transaction frequency and amount frequency. Why? Because when the Ether price rises, the normal users tries to invest in the cryptocurrency. So with this phenomena, this leads to a network sparsity and rapid fluctuation in the dynamic transaction network. With these challenges, the existing research are facing several research gaps. Now, what are they? First one is network sparsity, as I said earlier, which hasn't been addressed yet. Second one is the data leakage problem. Now, what is this data leakage problem? Data leakage is the problem when the future information is inadvertently used in the training period of a model. The large-scale network is often handled by the existing research by random subgraph sampling without following the temporal correlation. That means the temporal dependency hasn't been followed. That leads us to this data leakage problem. The third one is similar user behavior. Although some studies have addressed this similar user behavior, but they have suboptimal performance issues. We need to tackle this more effectively. And the last but not the least, as I mentioned, the fluctuations in the transaction frequency and amount. To mitigate these gaps, we have taken several measures. First one is to mitigate network sparsity. We have focused on individual user ego graphs so that we can get more attention to the user-specific behavior. Second one is to mitigate the data leakage, we have strictly provided the temporal sequencing so that no future information should be included during the training process. The third one is the similarity of user behavior has been handled by the contextual analysis of our model architecture. And the last but not the least, The fluctuation has been handled by the local and global temporal correlation analysis. What makes it the joint temporal dependency analysis? So we introduce catalog. The catalog model is majorly components are four components. First one is the local temporal correlation. Here we analyze the local ego graph of the users and with a overlapping sliding window. Here we analyze if there is a sudden fluctuations or any kind of aberration in the user behavior in consecutive timestamp, which is very prevalent in case of phishing users, that will be notified in this embedding. The second one is the contextual analysis. Now, what is this? We analyze the coherency between the past and future behavior of a particular user. That means if I am a normal user, I must be acting in a certain way. If I am a phishing user, when I'm mimicking a certain pattern of a normal user, and then I am getting acted with a high aberration, high input transaction values, there will be a fluctuation in the transaction. This context will be enhanced in this particular bidirectional contextual enrichment model. And the third one is the global context analysis. Global attention module is doing what? The deviation of a particular users with respect to the rest of the users in the same network is analyzed over here. So this threefold analysis is further joined with a weighted attention layer and followed by a classification layer. Here I would like to mention that while generating these embeddings, we maintain an unsupervised manner. That means we didn't pass any sort of labels till the embedding generation. The labels have been only set to the classification layer, nothing else. So these are the major contribution in our work. First of all, this is a contextually enriched user embeddings. Secondly, this captures the correlation of the local and global temporal dependencies. And third, it mitigates definitely the key challenges. Also, we have contributed a data set which constitute of 60,000 Ethereum transactions from 2024. Now, why this is necessary? The existing public data sets are from mostly 2022. So this is very difficult to handle the robustness of the model. We must need to know how the models are getting affected with the time-dependent changes of user behavior on the Ethereum. So that's why we kept this data set from Etherscan. And as we know that, as we can see that catalog yields a 7 to 8% improvement over the baseline. So the main research objective for our model is the first, how catalog is mitigating the Ethereum phishing scam detection problem. Second is how individual components, this correlation analysis, contextual enrichment is contributing towards the Ethereum phishing scam detection. And the third one is, does it really handle the data leakage problem and scalability as we mentioned earlier? To solve these questions, we have gathered this data set. The first three data sets are already available. As we can see that the timelines of this first three data sets are till 2022. But as we know from 2024 beginning, Ethereum has been emerging into version 2 and there is a high possibility users are getting aware of the Ethereum domain as well. So the transaction patterns, phishing tactics might get evolved. So that's why we have collected our data set. So these are the baseline comparison which is answering our research question 1. As we can see, the last is our model catalog is outperforming in the most of the cases with the best compared baseline trans to vec. One thing I would like to point out is the for data set D4, which is the recent data set, it is outperforming mostly because the D4 is the recent data set and the existing models are not encountering the recent evolving phishing patterns. Okay, so the next thing is the ablation experiment, which is basically showing the individual contribution of the components. As we can see that when we are merging all the components, although individual components are contributing on its own, but when we are merging all the components, definitely the performance is increasing. So that's why we are considering that all the components we proposed is definitely necessary to detect efficient phishing users on Ethereum. So the next experiment was the scalability and data leakage analysis, which was very important, as we mentioned earlier. So now for the data leakage analysis, we performed a sequential train test split. We trained the data with a sequential manner and tested with another sequential test size of the data. So as we can see that we are compared with Trans2Web, which is the best performing baseline. We can see that our model is surpassing the performance of Trans2Web in every cases of test cases. And the another one is when we are focusing on the ego graph, we focus mainly on 1:1 ratio, but to handle the class imbalance. As we know that there is a very less number of phishing users in the real world, but we wanted to see how much scalable our model is. To that, we have done till 1:7 experiment. We can see from the results that till 1:4, our model is having a consistent performance, but after that, it is declining a little bit because of the training of the classifier. It has less instances, that's why the training is getting affected. So this is the robustness experiment, as I told you that the training of the dataset, the embeddings has been generated by D1, dataset D1, which was the earlier dataset, but we tested with D2, D3, and D4. The performance is consistent of catalog as compared to two other baselines, Trans2Web and TTAVN. That means even if next time the phishing evolving tactics is like evolving or any kind of changes is happening, any version changes happening on Ethereum, still our model is able to handle that kind of fluctuations. So there are some limitations of our model, definitely. It was first of all, we didn't consider the explainability and interpretability. Whenever we are saying that this is a phishing user, we must know that why this is tagged as a phishing user. That gives it a very white box concept. Currently, it's a black box concept. So we wanted to work on that. The second thing is it has a data dependency. We need the future and past instances of a user to analyze the behavior over time. Otherwise, we can't just really say that it is a very good or user or not because of the 0-day attack. So we want to work on that. And obviously, we are thinking of real world deployment for the streaming data. So final conclusion is we proposed a novel framework of catalog by overcoming the key challenges of data leakage, network sparsity, and identical user behavior. And we have done this joint temporal analysis. And to the best of our knowledge, this is the first study on Ethereum for this joint temporal analysis. And last but not the least, the performance is good here. So thank you for your time. And these are the feedback.
So from that one, I have a thought question is that, what is the main response that we see in the world and the previous world, and why, the previous one is not comparable? What's the main difference in the trend in the future trend? And the second question is that according to the last paper, I saw that the technology is very resilient to the fluctuation. And what is the main feature that makes the technology resilient to the trend?
Okay, thank you for the nice question. So let me go back to the model architecture so that I can explain it to you. First of all, I would like to answer your second question first. That catalog uses a cross attention layer. We use a sliding window to the ego graphs, temporally evolving ego graphs, and then we use a cross attention layer which analyzes is there any changes in the embeddings. That means if the previous embedding is let's say one vector and the second embedding is another vector, is there any changes between these two by a cross attention? When this attention score is high, that means it is correlated enough. But it is when it is low, that means there is a change in the consecutive time window. In case of normal users, you can't have such sudden spike. If it is a spike, if there is a spike, then there will be spike for at least 2-3 windows. It is he or she is investing in the market, then the spike can go down. But in case of phishing users, generally the spikes are for very short span of time, because they give a very short span of time to the users to invest in the malicious wallet. So there, how we detect this kind of spikes and all, and this is what is a novelty of our model. And the second thing is how it is outperforming with respect to other models, other baseline models. In case of other baseline models, majorly what they have done, they didn't analyze this deviation from the global and local perspective. Either they have followed the local perspective, ego graph based perspective, or they have followed as a whole network they have taken care of. But we need to analyze this correlation is very important. There is a dependency. Whenever we are talking about a network, there will always be a dependency. That's what the graph neural network comes from. So that's why we need this correlation analysis. And this is another novelty of our work, that we analyze this correlation. That's why our model is outperforming other models. In terms of like new data, where our model is mainly outperforming others, because whenever the data changes, the correlations will also be varying. It won't depend on the data structure. It will depend on the user behavior. That's why it is getting more better. I hope it cleared your query.
Thanks for a good presentation. I actually have two questions. So the first one is, how does the phishing in Ethereum happen? So that's in the previous two talks, they focus on the phishing web pages. The phishing attackers may send a phishing email with a malicious link to the users, but how does it happen in the Ethereum network? Like, do the attacker also send an email to the victim, or they utilize the
Yes, thank you for the question. Yes, Ethereum phishing is different from the traditional phishing. Usually in traditional phishing, what happens, they send away emails or messages through a very malicious link. And if the user clicks on that link, they get steal with the sensitive information, correct? But in terms of Ethereum, they try to mimic the novice user patterns or normal user patterns to gain trust in the network, that yes, I am also a normal user, I am an investor on Ethereum, and you should invest with me as well. When they get the trust from that user, they set an investment trap. When they send away the malicious address, here if you invest here, you will get a doubling bonus or high return. The new users generally doesn't know about anything about this kind of investment. They fall prey in the trap and they lost money. As we know that any sort of transaction on any blockchain is irreversible and anonymous. We really cannot identify the face behind the trap or attack. We only have these transactions and we need to analyze the user behavior. So there's the challenge and differences. Is it clear?
Okay, thanks. That should answer my question. I have another question. So I saw that you use 4 data sets to evaluate your methods. So I was wondering if you train your model on each data set and evaluate them separately, or you, let's say, you pre-train them in some other data set to do the evaluation.
Yeah, so our model is a representation learning model. In that case, no pre-training is needed. The classifier needs a pre-training. For each data set, we can individually train the model by splitting it into training and testing set. And other than that, we have done a robustness experiment. This one, we have trained with the embeddings from the D1 data set and tested with the other data sets to maintain the robustness, because not necessarily we will always have the data. So that's why we have done it correctly. So we can do it both ways.
So we can expect that there will be some distribution shift across different data sets, right?
Correct. That's what we were targeting to identify in our model. Distributions won't be similar in all the cases because it's a real world setting. We just can't say that always the distributions will be same.
Thanks for your answer.
Thank you. Yeah. We can take the question in the comment. Thank you.
Okay, good morning, everyone. I'm Zivi, and it's my honor to be here to present our work to share of basic patterns, a unified taxonomy, multimodal detection, and security implication. So before we start, I have to introduce that this is a collaboration work that's between the University of Melbourne, Sarah Status One, and also the University of Canada. Okay, so we will what exactly is basic pattern. So here are the definitions for basic pattern is the lectures and UI practice that attributes into taking actions that are not in the best interest. Here we also have 3 examples. So on the left side is disguised, so it means the advertisements try to present as the normal content and hidden into the jurisdiction. And false continuity refers to, let's say you may see something like free trial for 7 days, and after that, how much money they will charge you. So false continuity refers to the user will be automatically charged after the free trial is done. And on the right side is hidden cost, so it means some kind of information. The additional fee will be shown at the final payment stage. So this information could be, let's say, the delivery fee or the service fee. Okay, so okay, so what's the relationship between, let's say, deceit patterns and security and privacy? So in our paper, we present 6 case studies to illustrate the security and privacy implication. Here we highlight 1 example. So this slide I would have already introduced above. So it is the advertisement that present as a normal contents in any part of the screen. So we did a serious analysis based on Alice and Moore model. So here we have some kind of information. Let's say the disguised eyes can mislead Alice into clicking on them and redirecting her to the site controlled by it. And also it can collect Alice data and track her activities to violating her privacy. And also Mary can launch some phishing attack or install the malware via the disguised eyes. And Trent, failed to enforce a clear ad labeling where it erodes user trust and security compromise. Okay, so summarize. These 6 case studies in our paper. We found that deceit pattern can expose cognitive biases leading to financial loss, privacy breach, and also breach trust in digital platform. We also found that the frequently deceit pattern render existing deceit detection method ineffective and leaving the user vulnerable. So we believe addressing these kind of issues is crucial to protecting user security and privacy, user autonomy, and also user trust in online interactions. Okay, so regarding previous work, we reviewed many recent studies and summarized this table. We found this work can be categorized into three parts. So that would be the taxonomy. So taxonomy is more academic, but normally, when people in the normal days always call it category. So, but in academic, it's called taxonomy. So we have taxonomy. Let's see, 7 studies over the past 14 years. Emphasize the need for the deceit pattern taxonomy to address the emergent UI design and deceit patterns. So for the data set, in early stage, we collect, or people will collect the data set and share them across, let's say, websites, social media, or YouTube video. But more recently, work have focused on constructing data set, but just for a specific period was for a specific categories. And for the detector detection method, existing approach are primarily either clustering-based or role-based. Okay, however, all of these recent work have at least one following limitation. So let's say, before we introduce the taxonomy limitation, I've introduced what is concept drift. So concept drift refers to a situation where the latest example are not recognized by previous models. So the latest example, which refers to the concept, drift refers it cannot be recognized by previous models. So that will cause the performance of this model decrease. So for taxonomy, the concept drift issue will cause the taxonomy outdated and the current taste is primarily on UI design perspective and overlook the security and privacy issues. And also for the data set, there's no data set that achieve cross-platform, so we call it comprehensiveness, or sometimes we call it cross-platform, large scale and also up to date at the same time. And for the detection, human effort is required, let's say, and human effort is heavily relied upon, let's say, for example, the cluster-based approach, humans need to give the label for the cluster or the group of the cluster. And also for the row-based, human need to manually maintain this kind of row table. So this makes the detection very, very challenging for adopting the context definition. Okay, so in summary, existing taxonomy overlook the security and privacy issues within DC patterns, and the available dataset does not achieve, comprehensive, large-scale, and up-to-date at the same time. And also the detection methods require human effort during the inference stage. Therefore, our research question is, how can we enhance the detection and characterization of involving DC patterns in user interface? Specifically, we are trying to achieve three parts. To achieve the cross-platform capability with a focus on security and privacy implication, and also we are trying our best to minimizing the human intervention. Okay, so for the taxonomy, the issue we have already introduced that is overlook the security and privacy issue. Therefore, we refine it as two levels. So we refine it as category level and also the scope level. So in category level, we remove one DC pattern categories and also add another new DC pattern categories. And for scope level, we expanded the use case of 5 existing categories. And for the dataset, we construct a new that's correct page. So for the dataset, we construct a new comprehensive, large-scale, and up-to-date dataset emerging from existing dataset and also incorporating some additional resources. So our dataset now is comprehensive, large-scale, up-to-date, and is also able to provide some rich insight for analyzing the trend over time and prove that the existence of concentrated issue in the DC patterns. Okay, so for the detection, we propose our model, which is called DBGuide. So it's a hybrid approach that combines a binary classifier for detection and also a multimodal lateral model for the classification. So for the detection task, which is in the blue part, we select several models and train or refine the model if it is available, and then we select the best binary classifier based on the FOS score. And also for the classification task, which we use multimodal lateral model, since we use some commercial multimodal lateral model and it does not allow us to fine tune it. Therefore, we introduce a POM mutation algorithm to optimize the POM in the POM mutation stage. So in the POM mutation algorithm, which is in the green part, initially we'll provide a very initial POM and randomly apply one of the POM mutation algorithm with strategies. Let's say you are going to paraphrase something, or you are going to add some action, you are going to delete some action, or you are going to swap the order of something, and then what we did is we use these kind of strategies to fill up the tree. And once the tree is filled up, what we did is we select, let's say, 100 samples and calculate the loss for each POM in the tree. And then we sort the tree and select the POM with the lowest loss to be the best POM in the next POM mutation. So once we have the best POM, the next part is about the inference. So when the best POM is obtained during the inference stage, which is in the original part, the images will first sent to the binary classifier to do binary class detection, and after that, all the suspicious images will pass to the multimodal lateral model for further check by using the trained POMs in the previous stage. Okay, so for the binary classifier, we experiment with several models. Let's say we have some commercial models, we have some DC pattern detection tools, we also have some fine-tuned pre-trained convolutional neural network models. So these results indicate that the fine-tuned ResNet 101 achieved the best performance. And also here we have the first takeaway. So that is a satisfactory binary classifier on DC pattern can achieved by fine-tuned or pre-trained convolutional neural network models, however, incorporating more accurate model into the framework will further enhance overall performance. Okay, so for the POM mutation strategy, we evaluate the final POM and confirm it actually works. And additionally, we evaluate the best harm loss in each one and found that, as you can see here in this diagram, the loss consistently remains lower than the solar model. So together, these two experiments demonstrate the effectiveness of our mutation strategies. Therefore, the other takeaway, which is on the left side, is this result demonstrate the effectiveness of the permutation algorithm in enhancing multimodal linear model performance. Okay, so finally here is our TBI performance on both mobile and also website platform. And as shown in the table, our model TBI achieved the best performance in majority of the categories. I think there's only one example that is excluded. And this demonstrates the highest overall performance across both platforms. So the next takeaway is TBI outperform the state-of-the-art model in deceit pattern detection, increasing the F1 score to 0.373 and 0.44 on mobiles, and also 0.5 and 0.34 on the website also. Okay. So to investigate further, we conducted empirical study across 1,000 applications and also 1,000 websites. And we found that 25% of these mobile applications and also 29% of these websites contains deceit patterns. And also we have some other findings. Let's say nagging was the most frequent deceit pattern on the mobile side, and also false hierarchy is the most frequent deceit pattern on the website. Okay, so before we finish, finally, on behalf of my team, I would like to express our sincere appreciation to the University of Melbourne and also Sarah Darcy's One for their research fund support. Additionally, we are grateful to OpenAI and also Google Cloud for providing free research credit. Okay, so a great news is our TOD guide is now available on this GitHub, and we also have written out-of-the-box code, so you can just using it for just 2 cents by just typing Python 3 demo.py. All right, thank you for listening, and I'm happy to take any questions now. Yeah, thank you. Yes, please.
Thank you for the presentation. It's very interesting work.
Please speak a little bit louder. Yeah.
Is it working? Yeah.
Yeah.
Okay. So my question is around when you said it's around the human trust angle, and how do you make sure that if someone is using the tool, like if the accuracy is around 80% or something, they can say that you were trying to reduce the human intervention in something like this, but how does they ensure that they can trust you?
Okay, so it's very easy because I hope you still remember in the example model there is one role which is called trend. So trend is the application provider, or it can be the regulator. And when we try to upload this kind of application to the App Store, we can use this tool. So besides our tool, we also have let's say GUI graphical user interface exploration tools. But we use that kind of things, to grab to get some screenshot, and then this screenshot will be sent to our model to detect if there's any deceit pattern or not. And if this deceit pattern is very high risk, because in the web conference in last year, we also have another paper that talk about the risk. So if we think this deceit pattern is very high risk, the application, the regulator or the app, the application provider will reject your application upload on their app store. So that's how we did. But that's for the application, and also we have some for the website. I think that should be the website domain providers responsibility to ensure that, because you can give us the website, and we can employ some tools to do the dynamic exploration, and then we can send some report back to the domain host or domain provider, and then it is their responsibility to ensure that if you want to block this website, or if you still give them access. Yeah. Thanks so much.
Thank you.
Yeah. And also, I think I put my email over here. So if you find there's any potential collaborations, or if you have any still have any questions, feel free to send out email. And also, we have the GitHub, so this is the paper, and also have GitHub, so you can, pull out some, GitHub issues on the GitHub and also, okay? Thank you so much.
Excuse me, guys. Technical issues. Hello, everyone, and thank you for attending this talk. Today, I'll be presenting our work, harmful terms and symptom on measuring and modeling and reduce financial terms and conditions in shopping websites at scale. And this work is going with several of my students here. Sai is the lead on that, working with Neil, Boyan, and John. And I'm a faculty member at University of Michigan in computer science. Okay. So, okay, so I'll be presenting this paper with, which is led by my student, Melissa Sai. In fact, there's a video posted as well, by Melissa, and I'm sure she's going to give a much better talk than I will. But I'm happy to take questions with you. Okay, so what is this paper about? So it's about these unfavorable conditions when you're doing online shopping. So here's an example where maybe you got a link in an ad or somebody sent you a link somehow on WhatsApp or email. You click on it, and what you're seeing is a very attractive deal for an item. And that's an example of something that looks like an AirPod of some sort. the deal is fantastic, it's $6.85. Shipping is free. Entirely, they say, okay, that sounds great. Going to your credit card number and buy. But it turns out that there's also terms and conditions which you're not quite when you're in the city of need that as soon as you buy. And that happens to maintain the subscription that sort of opts you in into a subscription for $86 a month. At that point, then your credit card starts being at that point. When you set the not holding that charge, it may even be hard to reverse the charge because part of terms and conditions. And so the student is not even guaranteed. Okay, and it turns out that this is not just financial phases, but even Celsius, which is a network of cryptocurrency, had legalities where essentially if they went insolvent, they effectively take all the customer assets. The customer assets were treated as unsecured assets, and therefore, in fact, it was ruled that that Celsius effectively owned the crypto deposits that customers had made with them. So it goes beyond that. So what we want to do is detect these unfavorable returns when you're entering a transaction in the web. So there is a definition that Federal Trade Commission has, which is that unfavorable terms and conditions are one-sided, imbalanced, or meticulous, and they disadvantage consumers financially. Okay. And there's a definition from FTC along that line, that if they cause financial injury without offering substantial benefit. Okay. Then often these have hidden consequences. They can involve difficult cancellations. And at the very least, one would argue that customers need to be informed about these charges or liabilities that they might incur. And so we try to measure, understand, and categorize these harmful funds. Okay, so we face three challenges. First, there's limited understanding. The landscape of these terms isn't well mapped out. Second, there's a lack of public data sets. No one has selected unfavorable terms at scale. I think the previous paper addressed part of that problem. So hopefully combined, we're starting to make some headway. Finally, there is no automated detection system to help consumers identify these terms. So, yeah.
It changed slides.
Yeah, I'm sorry, I'm having difficulty manipulating this. What's the easiest way to go to the next screen? I'm a math So I'm trying to find the right button to advance the slide. What's the easiest way to advance? Right, okay, thank you. Okay, so we face three challenges in this. One is that there's limited understanding. The landscape of these terms isn't well mapped out. Second is the lack of public data sets. No one has collected unfavorable terms at scale. And finally, there's no automatic collection system, detection system, to help consumers identify these terms. So our work aims to address all these three challenges. So we built a system called Term Miner, which is a pipeline for data collection and topic modeling. So, and that's actually released out as open source. We created ShopTC 100K, which is a data set, a large-scale data set of shopping websites on terms and conditions. And we designed then, based on that data, a taxonomy of 22 types of unfavorable terms. And we grouped them into 4 categories. And lastly, we developed a system like a prototype term lens which is automatically detects and flags unfavorable terms while users shop. Okay, so the term miner. It has three main steps. First, website identification. We start from the Franco top 100K sites, so 100,000 websites, and identify which ones are English. So we focused on English in our work, and that have terms and conditions. This gives us about 8,000 website candidates. Then we use automatic crawling to extract terms and conditions for these websites, which gave us about 1.8 million terms. Then we cluster semantically similar terms and topic model them. And that helped us spot prominent patterns and develop a taxonomy of unfavorable financial terms. So we analyzed over 22,000 topic clusters. We created a taxonomy of 22 types. And then they fall into four major categories. And the major categories are over here, which is purchase and billing. So these are terms related to payment, hidden fees, and billing practices. Then post-purchase, what happens after you get the ship, so return policy working in service limitations. Then legal issues like dispute resolution, liability limitations, like waiver of class action lawsuits, type of things. And then termination, we found at least one instance, which is in the appendix of the paper, where even after your account was terminated, they could continue to charge fees for account maintenance. So there was a website for which. Okay, so this gives you data about what data sets we used. So one was curated by us, the one that's highlighted, and two existing data sets on fraudulent e-commerce websites. So as you can see, our data set is much larger. We needed that. We collected nearly 2 million things and condition from these. And this data set is now available on Honeyface. For detection system, after we developed the understanding of prominent types of unfavorable terms, we designed a detection system. So the way it works is that on the front end, that one over there is the URL, the page URL that sends to the backend, and the backend then crawls and extracts the screenshot, HTML, plus the terms and conditions. And then there's a pluggable LLM module on the backend where you change the LLM model that's used. We do the image analysis if the LLM supports that. It's visual as well. On the screenshot, or we look at the text. And then based on that, we generate the alerts. And then that can be passed to the front end. We can also compare whether this alert was disclosed on the payment page explicitly. If it is, then you can suppress the alert. Okay, so we tested this on a range of language models and configurations from GPT 3.5 and GPT-4 to Llama 3 and Gamma in both zero-shot and fine-tuned settings. So fine-tuned model GPT-4o actually received the best results. So the false positive rate was 2.3, which is actually very good in this context. True positive rate was 92%. And the FL score was 96.6. And this was kind of the best result we got across various models. And we also then did a large-scale deployment or testing evaluation, where we applied termlens, which is the backend looking for like harmful terms and conditions to more than 8,000 websites and nearly 2 million terms and conditions. And we detected over 10,000 unfavorable terms broken down by various categories. So key findings from that data set was that, first of all, the unfavorable terms are present in nearly half of legitimate websites, not just fraudulent ones, indicating a systematic activity. So given that terms and conditions also often contain hundreds of terms and only few, like a big terms and conditions document, are really truly harmful, identifying them by users is actually quite hard. we need automated support. That's our system kind of contributes towards solution.
But how do you find a job like?
Another finding is that terms are even more prevalent on less popular long-tail websites, which is often where users get fed. So smaller websites are more likely to have these problematic terms. Now, the legal terms are often found on prevalent ones as well. So for future work, our work can be expanded in following directions. Taxonomy can be defined to track evolving terms and conditions language. We think as our work is out, the bad guys will try to evolve the language in some ways. User studies can be conducted to better understand how people perceive and react to these terms. And then possibly our work can help regulatory agencies help inform them in terms of coming up with better standards and improve consumer protections. And again, we have open source term miner and the dataset with the hope that the research community will build upon these resources to advance the study of unfavorable financial terms and develop effective solutions. With that, thank you so much. Yeah, so when we did this work, DeepSeek wasn't available at that point. So it's worth considering. I think the cost side is one barrier, certainly, because like if you look at term lengths, what we have, the front end, the back end, the back end needs to use some sort of model, and there's a cost currently for making these queries, and that's actually one barrier. So finding a way to lower that cost, possibly to zero, would be a great thing. I mean, ideally, I would like that to be entirely local. We are not quite there yet in terms of, yeah.
So this is really a technical question, more of a semantic one.
Yeah.
How do you define a bad terms and conditions? Because to one person, it may not be a bad term and condition.
Sure.
To another, it might. And how do you quantify how bad it has to get before you raise it as a flag? Like if it's 1 cent per day forever, that might be bad in aggregate. Doesn't look too bad as a term. And so I'm curious how you managed to tease out the semantics around what's a bad term.
Yeah, so it's a great question. So partly it's using these language models, in this case, ChatGPT 4.0 to help out. But what we did then is created a subset of that data set, the analysis that GPT 4.0 gave, that was through prompts, like essentially asking, giving you, and that's in the appendix of the paper, in terms of what prompts we used for getting that input. But then we also had 3 researchers manually code the harmful terms and conditions to see that. And then we use that to fine tune the model, the GPT 4.0 model, created a fine-tuned version of that. And then that was kind of then finally used in the comments system. So there is a combination of automated techniques plus human. Yeah.
So the incremental.
Yeah.
What you're doing is incremental static. Now.
Possibly. And I think that's an open area. That's one of the future directions I think that needs to be explored. Yeah, I mean, I think we can discuss offline. We have, I mean, you can think of it as we have a taxonomy of some sort, right? And the bad guys are going to try to avoid it. And I think that's going to be a cat and mouse game to some extent. So like one example, someone pointed out yesterday to me is that if the terms and conditions were like in PDF, instead right now they're in PDF format or text format, but let's say they were screenshots, that would require now a different technique for analysis.
could be one example. But that also creates a new anomaly, which is saying, why are they in a screenshot form, for example? So I think one would have to look for language that's not usual in some way, and say that's an anomaly, and that requires further investigation at that point. And that would have to feed into some crowdsourced data of some sort, if that happens to be the threat. But these are the common ones currently on these websites. Yeah, maybe, yeah.
Yeah, so question about kind of the broader landscape of terms of service, like this has been a problem for a long time, right? Where they're so long and they cause all these harms. This is one kind of harm, but there's others. And so I'm wondering if you think this type of technique can be a turning point, and what do you think the companies will do as a result, right? Like, because it's not like they're gonna sit still and wait for their whole surveillance and manipulation to be revealed. So I guess the question is like, where do you see this going now that you have created this potentially powerful weapon that we haven't had at this fight?
So my hope is that companies, the browser companies, first of all, pick up on some of this work and incorporate some of the defenses that we are suggesting. So like Google is in a much better position, for example, as a browser company, to potentially improve their alerts on these. So currently, the browsers fail for the most part in detecting these right now. But you could imagine a version of the browser that is actually proactively looking at that and helping the user. And they got the back end too, in terms of where they can absorb the costs of the doing. So that's my one hope there. And that then gives a platform to potentially improve. Now for researchers, I think there's also lots of open questions in terms of HCI issues, in terms of how to generate these alerts, whether users find them useful, and so on as well.
Thank you for breaking down. It was just a simple key question. So what was the ground force to evaluate the performance of your framework? So the number of first positive markers.
Yeah, so as as I said, that the core data set after the distillation was human annotated by 3 people. And then there was discussion if there was controversy, and that helped create the fine-tuned version of the data set, which was then used, or a subset of the data set that was used for fine-tuning the model. So it's human inspection in some sense, is the conclusion.
Thank you so much for I was just wondering how the quality can correctly identify the term and condition given that like you have to that's different, because I was assuming that they're not gonna show you, not our website will show the same thing when you access the website. Maybe you need to sign out with how the product can correctly identify the term condition, because I think the product don't really, necessarily component of your system. So how can it correctly identify? How is overcome, like for example,
Okay, let me rephrase the question, see if I got it right. Are you saying that you might be visiting a website that's private and there's a backend and can't see it?
Oh, no. I'm just saying, how do you correctly identify, like, where do you know how the product can find the term and condition on each of the websites?
Yes.
This might be different for the
Oh,
website, right?
I see. Okay. I mean, we are using a set of regular expressions and things of that nature to identify the terms and conditions. And yeah, those, I think there's a possibility somebody could try to evade those patterns, and that would again be another cat and mouse game for that. And I mean, we are using also screenshots where the LLM support that, and that might help as well in terms of visually if there's a disclosure of terms and conditions. The thing is that if they don't actually do it correctly there, then they possibly also are giving up their rights to, if a credit card charge is disputed, to be able to take back the money because it's not properly disclosed. So I think there's a bit of balance there where websites can go that far where they completely have considerations. Yeah, and I'm happy to take more questions, I guess. Maybe there's one back there if there's time back there. Last one.
curious, how formulaic are the bad terms in terms of their phrasing? Is it very, very diverse, or do you get very common patterns? Because you mentioned that there's a cost associated with running the GPT API calls.
Yeah.
If they're quite formulaic, could you try a simpler model that you just run locally?
Yeah, we don't think so. There's a fair amount of variation in the text language that a simple regex type filter, for example, won't work. We did not try simpler models like BERT or Roberta type situations, or ResNet, like in the previous talk, but I think the F1 scores that you're seeing with these advanced models are much better than maybe what using simpler models, etc. You're seeing. So there seems to be some value in these more advanced models, foundation models, towards improving this right now. It's a great line of investigation. Thanks so much. Okay, thank you so much.